This meeting is being recorded.
So we've now finished the intro to Fab Academy. We've done the presentations, we've done the world tour. And now we're going to start in on this topic. So as a reminder, after each class, I'll be posting the video. The videos will have transcripts and we'll be doing translations. So the remainder of today's class introduces project management. The assignment is work through a Git tutorial. I'll explain that. And then build a website that introduces you and your final project. And I've got linked some examples of both websites and work on it. This was one from Nadia. This was a nice one from Leon. Here's another good one. These are examples of both websites students built and them describing their lessons and experiences. So there's more here than I can cover in the time. I'm going to focus in on the key things we need. So you're going to be managing projects. You're going to be building websites. So let's see. Let's go back to Nadia. So see Nadia. Oh, let's see. This is a more general site she did. So let's see. Let me. Let's come in. So you're going to build a website. It's going to describe yourself. Here's Nadia. You're going to do weekly assignments. For each week's assignment, you're going to build a notebook where you make a log of your work. So here's Nadia describing what she did. Yeah, she documents unusually well. You'll be documenting your weekly assignments. We use those to check that you did the work. You're going to use these pages. You're going to end up referring back to them, you'll find. And then other students are going to learn from what you did. You're going to learn from Nadia. And every year is slightly different. Other people will be learning from your work. So to do that, you need to build a website and you need to get it onto the server where we're serving it. So this first note is not something you need to use, but just to be aware of. Synchronization is you have files on one computer and you want to have them mirrored in another. So rsync is something I make a lot of use of. Rsync very efficiently gets two computers to have their files in the same state, and it works on giant file systems. I use this uh, on servers that have terabytes of data to mirror them on backup servers, for example. Version control goes beyond that. And there are a number of different version control systems. We're going to be using what's now the most common one called Git. And Git does many different things. As a beginner, it's going to be one of the most frustrating things. And then as you progress, it's going to be one of the most powerful things. So what distributed version, what Git does is it keeps track of multiple versions of a project. So you can have your current work, you can have testing version, you could have versions in different languages. You could have versions on multiple different computers. You could have multiple people working on the same project. What Git does is keep track of multiple servers, multiple versions, multiple people, and keep all the work consistent across them. So Git is the tool that you're going to use to log your work. And I'm going to descend in and tell you much more about it in a little bit. And then GitLab is a platform we use for Git. So um, Git is an open source project. It's named after Linus Torvalds, and the origin is in British English, a Git is an annoying person and Linus is an annoying person, roughly. It's really that simple. So he originally helped create Git. It's open source, very well documented. GitLab is a platform along with GitHub for using Git. So these are cloud services that let you use Git, but you can also use it locally. And I'm going to tell you much more about that. GitHub was bought by Microsoft. It's the most common, it's a commercial platform, but it's one of the most common homes for open source software. GitLab is a both open source and commercial version that you can run as a private cloud. So Fab Cloud is a installation of GitLab. It lets you use Git on a web server, and along with that, it provides a number of other services we'll be using. So I'm going to go on and talk about web development, and then I'm going to come back and go in more detail and talk about Git. Yeah, Hank, I'm going to get to that link. The reason we're using GitLab, not GitHub, is you can't run. So to use GitLab, just Microsoft bought GitHub, and you have an account on Microsoft's GitHub. GitLab lets us run it. There's an open source version, and it lets us run our own installation. So GitLab lets us create accounts in our cloud, lets us manage services through it. It lets us manage communications. You can think of it as a private cloud version of GitHub rather than having identities in Microsoft's platform. So I'm going to come back and talk about the archive in a lot more detail. So with your account on GitLab, you can edit web pages through the web interface, and you can also edit them on your local computer, and I'll be talking more about that. You're then going to need to build web pages. So right now you're looking at a web page. You can serve web pages just by opening the raw files. You can run local web servers. We're going to be making a lot of use about both JavaScript and Python in the class. And both JavaScript and Python have web server modules you can use to do web serving. I'm going to type Control U. Control U lets me see the source. So right now you're looking at raw HTML codes. So HTML is how you mark things up for the web. At the lowest level, you can just write HTML directly. And so most of my web pages, I don't use any other tools. I just simply edit HTML. There are many templates available. So this is templates you can use to build your website. And so something I suggest is if you see nice websites you like, just you can view source to look at the HTML. The lowest level of building websites is to edit the raw text. So I use an editor called VI. VI is decades old, many decades old. I think its history is about 40 years. The reason I use VI is it dates back to before there were even keyboards and mice. And what that means is it doesn't assume keyboards and mice. And what that means is you can keep your fingers on the keyboard, but you can sort, search, filter. You can do all the things you do with the user interface without your fingers having to leave the keyboard. And so uh, um, it's both old fashioned, but in a sense, it's more advanced. It's very efficient. So that's why I like to use that. These are all more recent editors. I'd say VS Code might be the most popular one as a very powerful open source editor platform. These have profiles for everything we'll be doing, which includes writing low-level code, high-level code, and doing web development. So you can use these as web editors. Then LibreOffice is an open source office suite, and it's got a tool that lets you do web development. SeaMonkey is an integrated multifunctional tool that includes web development. And Dreamweaver is a commercial tool. All of those let you do what you see is what you get web development, where you change fonts, click and drag, move stuff, and you don't see the HTML. It's just like using a word processor. What's good about that is you don't need to learn about the codes. You just do it in the GUI. In part, what's bad about that is the HTML code they produce tends to be pretty ugly. So if you use them, you have to stay in them. But it lets you do it with a graphical interface. JavaScript, we're going to talk a lot about when we in multiple ways. We're going to use JavaScript to interface to embedded devices. We're going to be writing JavaScript to make interactive applications. And so it's a programming language you use to activate web pages. We'll see that later when we get to interface application programming. These are then frameworks where instead of writing HTML code directly, you write in a higher level language. Markdown lets you write human readable code that just looks like annotating, like dashes and circles and tabs. It gets converted into HTML, but you don't need to know about the codes. It lets you do it human readable. And then these are frameworks you can use to build websites based on that. And then YAML is production workflows. When you edit your web page, it has to get published on the website, and YAML is what gets used to do that. So each of you has a raw web page. If we go to, let's see, if we go to the students, oh, actually, yeah. Yeah, I'm gonna. Some of them. Let's see. Yeah, quite a few have already gotten started on your web pages. This one is just a basic template. So if we take Anderson from Isan, in GitLab, let's see,
que natural puede ser un poco más complicado, pero al natural el azúcar en...
Sorry, are you asking a question or need to mute? So what I want to do is just show you a very small example. So the let's see, I'm looking for the Isan. Let's see, this is Centro Innovation. Okay, so students. And okay, so here's a website for Anderson. Here through GitLab, I've descended into it. The YAML, here's the little bit of code that publishes it, and then here's his website. And so index.html is his root page, and so here's his web page. And so I'm going to edit. There's a web interface that I can edit it directly here. So I'm going to open it to edit. It's starting up the web interface. And I'm going to say H1 is a header. This is a demo in class. So I'm going to commit that, which is like taking a snapshot of it. It gives me an option to create a branch. I don't need to do that, so I'm just going to say commit it. So I just edited that website. If we now take that repository, it's now building the website. This tells me the pipeline is running, building that small website I did. It just finished that. Now if I go here and I reload the page, let's see, I guess it hasn't published yet. So yeah, in a moment, we should see the edit I just made. Let's see, Julian, why do I not see it yet? Has it not just been published?
Sometimes it takes a bit, yeah.
Yeah, so even when the pipeline is finished, yeah, I'll leave that up. It's funny, the pipeline says it's done, but the server is still working. Okay, so that I just did a very small edit on a student page. If you go back to the student pages, you'll see quite a few have already started building their sites. So here's Burak's site. And then if we look at the source, you can see the code he's using to build his website. All of that is editing the raw web pages. You can progress beyond that by using Markdown and MKDocs to do site building. And again, as a reminder, if we go back to the schedule, on Monday at 9, Julian's going to be doing a recitation on everything I'm covering now.
You see now deployed here.
Okay, so yeah, it took a minute to appear. So I made the edit. So in the web interface, I edited the web page, and then here you can see the content. So it'll take all semester to really begin to master web development. Initially, you'll just be making small changes and then bit by bit progressing. Now let me descend in to talk more about Git. And then I'll end with some on project management. So GitLab contains repositories. A repository is a file system along with its history. GitLab, in addition, has interfaces for editing. It has issue trackers. And so if we go into the class site, let's see, the issue tracker, sorry, Julian, remind me which issue tracker. It's the class issue tracker, correct?
Class, yeah.
Yeah, okay, so this is the right place. So in the class project has members, all of you, and then it has, for managing it, it has issue trackers as well as tools like what are called Kanban boards, wikis, milestones. And so with the issue trackers, so I'm going to post an issue. This is a sample issue. So I just posted an issue. You should have gotten an email notification. This is a response to the issue. So I'm going to respond and then I'll close the issue. And so you'll see lots of traffic on the issue trackers. We use them to ask questions, answer questions. Using the class issue tracker goes to everybody in the class. So don't use it for something that you can do locally, but use it for things where you want to both share with the world and where you can't get answers to local questions. And so we'll be using the issue trackers for communication. And then GitLab has all of these other project management tools, wikis, milestones, Kanban boards. It has APIs for automation. As we progress, we'll be using some more of all of those. Git has a very good tutorial. You can't learn Git just by clicking and dragging. You really need to work through the tutorial. There's basic concepts, which includes committing, branching, and merging. And so in Git, there's the files you see, but there's another part of the file system, which is the history of everything that happened before. And in the history of a project, there can be multiple versions over time that you do diverge and converge, and that's called branching and merging. None of that'll make sense until you work through the tutorial. So you really need to go through that. This is a good guide to Git. This is a good Git book. This parable is a nice story about why Git exists. Dangit is a really nice site for all the things that can go wrong with Git. And this is a nice page on missing things, including use of Git. There are multiple ways you can use Git. So first of all, when you use GitLab, you're using it in the cloud, but you can run it locally. It's available for Linux, Windows, Mac. There are graphical interfaces that let you use it locally. But crucially, you can do all of Git just from a terminal. So bash is the name for a basic command line terminal, the most common one. In a bash terminal, these are basic commands you can type. And you'll find initially as a beginner, you'll just be using Git in the cloud. You'll be going to the website, but very quickly that's frustrating. You're going to have lots of content that you want to get on the website. You have lots of different tools you use to manage the content. And so as you progress, instead of clicking and dragging on the web, what you're going to do is you're going to work locally. So you're going to clone your repository, which is making a copy on your computer. You pull to get the current work. Status tells you what you're going to be doing. You add your new work. You commit it, which is like think of it as taking a picture. And then you push it back onto the server to publish it. And then merging and branching and forking come when you collaborate. So once again, you don't need to do that initially, but very quickly you want to get set up so you can do all of that on your local computer. As a beginner, it'll be frustrating. As you get used to it, learning to do Git for version control is one of the best skills you'll take away from the class. On Macs, you can do it in Homebrew. on Windows, you can install what's called the Windows subsystem for Linux, which is a complete Linux subsystem. It's the easiest way to do it from Linux. And in Linux, it's baked right in. This script link is when I set up a Linux server, these are all the commands I run. And this is one of the most important productivity tools in my life. Here I'm calling this up. If you've ever been around me, you'll see I'm often at a terminal that looks like this. What I'm doing is on my phone from Android, I'm running Termux, and this is for iOS, and it gives you a shell that lets you do everything I just described. So each day I pull a Git repository, that's everything I'm working on. I go through my day doing my work, and then I push the repository at the end of the day. And so doing Git on my phone is one of the most important productivity tools for me. So you'll install Git, then keys are, when you log into the server, you do it with a user and a password. When you're working on your local computer, your computer has to authenticate to the server to tell it who you are. And so you use that with what are called keys. These are cryptographic secrets. And so you produce a key and you use it to tell the server who you are and how you can push and pull. And in the Monday recitation, Julian will go through how you create a key, how you put it on the server, and then how you use it to push and pull. And so there's a lot going on here as you get used to it. You're keeping track of the history of your work, you're merging changes, you're collaborating, and then you're doing remote server management. You're working on your local computer, but you're pushing work on the remote server. Now, there's a number of common mistakes. I'm going to point these out. Many of you will make them. We'll need to keep an eye on them. Initially, these are just software mistakes. It gets more serious when we get into hardware. So you need to set the location and the permission on the keys. Otherwise, Git won't be happy. Your network has to allow you to not block talking to the server. Down here, I have a series of Git commands. You can do all these from graphical interfaces. These are the versions you type in a terminal. Git status tells you what you're about to do. A common mistake is you have a directory of pictures, for example. You don't want to commit all the raw pictures. You want to just commit the ones that you're using in documentation. But you can accidentally commit a whole directory that has nothing even to do with the class. So Git status is very important to check what you're going to commit before you do it. Before you can push to the server, you need to pull and merge your work. After you push to the server, you need to refresh your browser and wait for the server to finish, like I just saw. You're going to build a website. A common mistake is you want to point from your web page to the files locally. You don't want to describe where it is on your computer. You just want to describe where it is locally. And so that's relative paths. You don't want to describe where it is. The server cares about upper versus lowercase. Some operating systems don't. And also, non-standard characters need to be escaped, and you should avoid them. This is an important one, which is we want all of the work you do in the class to go into your repository. The only exception is very large files that can't be compressed. This is because this is archival. Links out to wherever you keep your stuff break fairly quickly. We want to archive your work for posterity. And then a very important one is the size. So we want you to produce megabits of data per week. so that each lab produces gigabytes per semester. So it's important you check the size before you commit. And in next week's class, I'm going to talk about a camera can take a gigabyte image, but that's a whole semester's worth of work. Images for web resolution should be tens of kilobytes, not gigabytes of raw. So next week, I'll talk about how to compress images and how to compress videos down to web resolution. That saves space on the server, and it's friendlier to the people viewing your page because your pages load much more quickly. And so this in particular, some of you are certain to make a mistake and commit files that are too large. I'll be keeping an eye on file sizes and showing examples of that. So once you get set up, git config is where you tell Git who you are. SSH config is where you tell Git how to find servers. You can tell it to exclude common files that you don't want to have backed up. And then here's a series of Git commands. Config is setting it up. You can experiment with Git with your own directory. So you can make your own Git repo and initialize it and clone it locally. Clone is where you get a copy from a server. Pull is where you get new work. Push is where you push your work back. Status is what's going to happen. Add is where you add new files. Commit is where you add a message and take a snapshot of your work. Log shows you the history. Remove removes a file from tracking. If things go wrong, you can reset the repo. If things go really wrong, you can just clone and start all over again. And then as you progress, you won't need this initially, but you can start to have multiple branches. Branches are for things like different versions, different users are where you'll start learning about branches. And then these are some more advanced commands that you won't need. And then I do this so much, I have a bunch of just shortcut commands. And so these are shortcuts I use rather than typing all these words of just few letter commands. These are the most common commands I use. So once again, as a beginner, you'll just use the web interface and do it all from a web browser. But then over the coming weeks, you want to get set up so that you can work locally to be able to push and pull. Okay. This will seem a bit abstract, perhaps a bit challenging, just as you're first encountering it. But as you settle in, comfort with both Git and web development are very important skills you'll take away from the class. So once all that's done, you're going to have a website built and you're going to be working on your assignments. One of the biggest challenges in this class is going to be your time management. Every week, you're going to run out of time. You're going to want to do more. And then when we work towards the final project, you'll really be racing the clock. So although it's not quite explicitly the focus of the class, time management and project management is one of the core skills in the class. Git does include a series, a Git lab includes a series of tools that can help you with that. So if we go into a project, one of the things it has is these boards. And what these let you do is define a series of stages in a project, make a series of issues, and then you can move these through the boards as a way to track progress. These are all programs that help you with project management. These are all programs that let you keep track of tasks, when tasks get done, and how they depend. And I'm going to be talking more about those later in the cycle. So there's a new class we're adding on system integration. And in that class, as we get towards the final push, I'll be talking, let's see, I'll be talking about that. Here are some general principles. So what I'm going to say now will sound almost like common sense, but it really isn't. Each of these you're going to run into. I'm going to say them at the beginning, and I'm going to repeat all of this at the end. So 80-20 is a construction system, but it's named after the 80-20 principle, but I would really call it the 95-5 principle. This is the final 20% of a project takes as much time as the first 80%, or I could say the 5% versus the 95. So when you build a house, you quickly get all the framing up, but like all of the wiring and finishing surfaces, what seems like the last part can end up taking the most time. So when you do your final project, many parts of it look like they're going to be hard, but they'll go quickly. And then the last few percent to finish it, that looks like the easy part, ends up taking almost all of the time. So integrating and finishing systems is easy to miss. It looks like a little detail at the end, and that can end up being much of your time. Demand versus supply side time. So demand side time is you do a task, then you do a task, then you do a task, which sounds obvious, but if you needed to finish here, you ran out of time. Supply side time is you start in advance, take the time you have, and you divide it up by what has to happen. So demand side time is you read a Git tutorial, you read an HTML tutorial, you start building a website, but this all needs to be done by next week. Supply side time is you make a schedule of the week. So here we are today. Next Wednesday is the class. And so you can afford, say, a day to do the Git tutorial. You can afford a day to practice with Git. Maybe on the third day, you start learning HTML. The day after that, you start building your website. But you make a schedule not based on the tasks, but based on the time. And then to a surprising extent, you can figure out how to work within that schedule. And so you do as much as you can within the time you have, and then you stop and go on. So it's very important you get in the habit of working to the calendar, not the task. In advance each week, make a schedule for that week and respect the schedule and work to it. And that's going to be essential when we get to the final project finishing. Triage is when a plane crashes, the first responders need to figure out who's so injured they won't survive, and you have to give up on them, who's up and walking and doesn't need immediate medical attention, and who's right at the boundary where they can survive if you help them. Your projects are going to be like that. You're going to have parts of the project that are in such bad shape you need to give up on them. You're going to have parts that you have no trouble finishing, and you need to identify the parts of your projects that most need your attention. So sort of doing disaster response on your project, like a plane has crashed, is an important skill. Serial development is you do task, 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 but if one task gets stuck, you block all the other ones. Parallel development is you keep all the tasks working in parallel, so no one task can block all the other tasks. Spiral development, you're going to get tired of me hearing it. Straight line development is you start at the beginning and you finish at the end. And in the US, the Department of Defense would spend 10 years buying a system and discover it didn't work at the end. Spiral development is you work in a series of larger and larger spirals, but each time you come back with a system you can test. So let's say you wanted to make an electric skateboard. The first spiral would just be a sketch. The second spiral could be a cardboard laser cut version, but that doesn't have any electronics. The third spiral goes from cardboard to wood. The fourth spiral goes from wood to composite. The fifth spiral adds a motor, but it has a tether. The sixth spiral gets rid of the tether with a battery. But each spiral, you come back to having a system you can test. And that's going to be a really key principle to work in spirals rather than in straight lines. Debugging is going to be a big issue. You're going to make things that don't work. And so we're going to talk about bottom up versus top down debugging. A very important principle is making things that are modular so you can debug modules separately and then combine them. And another thing you're going to get tired of me saying is document as you work. I showed you, for example, Nadia's beautiful project documentation. It doesn't work to do your work and then at the end document, because you're always running out of time. And a really important skill is going to be learning to build documentation while you work. So each work session, let's see, I'm going to add a note to clean also. So each day's work session needs to end with documenting what you did in that session and needs to end with cleaning up after the work that you did. You need to get in that habit to keep up with your documentation. Otherwise, you're going to be struggling every week. This is a really good book about project management from the person behind the IBM 360 that describes many of these lessons. Each of these sort of sounds obvious, but billions of dollars have been ruined by failures in these project management skills. And these are things you can really learn to think about explicitly. So let me step back. I want you to make a sketch of a final project. The final project can be changed, but I want you to have a starting idea. Some of you will change your project down to the last week, but if you firm it up early, you'll make better use of time because you can use each weekly assignment to work towards the final project. And then I want you to build a website. You each have a rough starting site. And I want the website to describe you and your initial idea for a final project. So that's the homework for this week. Saturday will be the open time that can help with anything. And then Monday is the recitation, where Julian's going to descend in more detail into things like how you put your keys on the server, how you clone the repository. Remember, you have lots of help. In your labs, your peers have lots of experience. You each have your local instructors. There's regional reviews to help you regionally. The global open time. There's Mattermost for conversations. And then there's the issue trackers. You have issue trackers in your lab. You have issue trackers for the whole class to answer questions, are all resources to help you. Okay, and we're almost out of time. Any questions? Any comments? For files too large to compress, video will compress down. That's megabytes a minute. One example is raw 3D scans turned into meshes. Those can easily be gigabytes. That's one of the few cases where we can't compress it down. Any other questions? Oh yeah, let's see. The question in the chat. Let's see. The Siddhat is asking a really good question. Each week, so next week is design tools. I'm going to give you links to lots of different examples. As we talk, I'm going to narrate. So the breadth is I'm going to give you lots of examples. As we talk, I'll narrate particular ones to focus in on. But one of the main ways to help you navigate that isn't going to be me, it's going to be you. Meaning, next week's class, the first hour and a half of the class is going to be running the random generator, meeting students, and we're going to look at what each student used. So during the first half of the next week's class, we're going to tour what worked, what didn't, what was productive, what was helpful. And so this class on web development isn't over now that we're up to 12, it just begins. Now you're going to go work on it for a week. Then next week, we're going to debrief it. And it's only after that it starts to make sense. So it's the cycle through me introducing, you working, and us reviewing that helps you orient to each area. And in each area, there's really 3 different things we're doing. You can't learn all of embedded programming in 1 week, but in 1 week, you can learn what embedded programming is. You can learn an example of how to demonstrate it, and then you can learn where to go to learn more information. Okay, that's a good question. Any other questions? If not, the goal this week is just get you started with Git and web development to get you started thinking about projects. So come take advantage of global open time. As Rico notes, this is the way. Take advantage of Julian's recitation. I'll be posting videos after class. And then with all of this introductory stuff, this is really all just introduction. Next week, we start in on engineering with the design tools. And then the week after that, we get in the lab and start making things. So you'll come to really appreciate the community that, so many of the people, commenting in the chat started as students, became instructors, now are anchors of the program. You'll get to know them. They're wonderful resources, and eventually you'll become them. So to end, a nice tradition is we say goodbye to the class all at the same time in your local language. So we're underway. Bye-bye.
Okay.
Estás,
Okay,
Spirit?
bye.
Bye bye.
Bye.
Adiós.
Dios.
Adiós, adiós.
Bye bye.
Chao a todos.
Chao a todos. Gracias.
Bye.